All right, so it's 12:02. Let's get started. So, hello everyone, welcome to Ask Seminar Series. This is a last seminar this spring, so it's just unbelievable. It goes so fast. And so today, we are going. This is an in-person seminar, but it's also streamed by Zoom. So I believe we have a lot of online attendees. And for the online attendees as well as in-person attendees, just so you know that we'll have the Q&A after the presentation. So please feel free to bring up any questions you may have. Since this is the last one, I just want to let you know that let's conclude strong. And we will resume our seminar in like the around like the beginning of September. So please stay tuned. And before Mike gets started, just so you know, all the management is here, our director, Lars Peter, and our associate director, Ralph. And so I will hand the ball over to Ralph to introduce Mike. So
Yeah,
go ahead.
Thanks, John. Yeah, just I want to say a few words about our speaker. So Mike and I have known each other a really long time, back when was that? Like
2007.
2007, when we were on campus, and he came on board to install a SWOT hydrological model, I believe, or you worked on that. And Mike's done a bunch of different things at ESSEC. And so there's an old saying, jack of all trades, master of none. That's me. Mike's a jack of all trades, master of everything he does. All right, so that's Mike. He's done a bunch of things. Done some you were at the help desk for with Mark's team, and he also has done work at Goddard on some climate work with people. He also worked with us on the Cygnus satellite project, looking to see if that could look for flooding. And then when this project started, we needed somebody to kind of run it. And Mike was the logical fit. So it's hard to believe it's been 3 years on this project. And Mike's a Terp grad. He's from the area. He knows everybody. So he's really been the glue to keep this project moving ahead. So he's going to give his talk as sort of a reflection of how you engage with stakeholders. So turn it over to Mike.
Thank you.
So before I get started, many moons ago, we were sitting at a bar with some friends, and the bartender said, "You're like Chatty Cathy. They just pull the string, you just won't shut up, right?" So I call that outgoing. Some people call it different things, but it lends itself well to working with stakeholders. So this is one of my favorite slides in the whole wide world. Basically, this was a review article. And what the author here is saying is, traditionally, do I have a mouse? I don't have a mouse, do I? Traditional science is over here on the left, outreach and translational science is over here on the right. And he calls this the mucky middle. I call this where science goes to die. And so what I've been focused on and what I do is try to move this to here and try to move this to over here. So that's kind of how we're going to work through this. So what is a stakeholder? So we need to have some common definition. So a stakeholder is anybody positively or negatively affected by a project or policy, initiative, research, organization, whatever it is. They can be inside or outside the organization. When I'm talking about an information user, talking about somebody that's just using that information to make one small decision that only affects them. And when we talk about decision makers, we're talking about people that can influence policy, regulations, things of that nature. So if you think about a weather forecast, so the weather forecast comes out, I look at it and I say, I need an umbrella today. That's great. So I'm a user. I use that information to grab an umbrella. So the decision maker at emergency management looks at that forecast and says, well, do we have a possibility of flash floods today? Do I need to open the heating centers? Do I need to open the cooling centers? Do we need to get the snow plows out? Over in operations for the school system, same thing. Are the buses going to be delayed? Do we need to go to school early, late? Do we need to cancel? So just from the weather forecast, depending on where you sit and who you are, that information can be used multiple ways. So that's one of the things that we always have to be cognizant of when we're putting information out there is how is it going to be used? Why is this important? Well, if you have support from the community before you start, adoption is much, much easier for the end results. You're most likely, if you're working from stakeholders from the very beginning, the outcomes are going to be a lot more credible. They're going to be a lot more relevant to their uses. They're going to be a lot more legitimate in the eyes of the stakeholders. You know, if you sit for 5 years in your office and then show up one day and say, hey, I made this great tool. This is awesome. Everybody should use it. Well, if you didn't consult anybody while you were developing that or talk to stakeholders or understand how they're going to use information, how they're going to make decisions, your tool might not be fit for the purpose. And then federal funding opportunities, if you've been watching them lately, a lot of them are asking for stakeholders. So these are direct quotes. One's from iOS, where you had to have a transition principal investigator that has a written transition plan to connect it to user outreach. So one of your PIs had to be a transitional principal investigator. And the other one is from NASA Innovate. End user organizations must identify and include in the proposal development a user of the tool you're developing. So, you know, you're starting to see this, especially in this new administration, a lot more of this applied science where you must have a stakeholder on your team and you must have an end user in mind when you develop these. So that's the why, that's the who. How do we cultivate stakeholders, users, and decision makers? So these are some of the pictures from around, but number one, what do you have to offer a stakeholder? What are you bringing to the table? You know, if I show up and just say, I need you to sign on this proposal because I want to get $1 million so I can do my research, is that really gonna go anywhere? Does the stakeholder really care? You know, you have to bring something to them that they can use. You have to have some sort of value proposition. Don't be afraid of no. Before you started, the answer was no. You're not anywhere different than you were before if they say no. You just have one more person you don't call next time. So a lot of people are afraid to go out there, put themselves out there and be told no. I get told no all the time, but I have a contact list of over 500 people that I can call at any moment over the years. So everyone knows everyone. So when you go out there and start talking to a stakeholder, you go talk to somebody at the Dorchester Public Health Department, she knows the director of the Department of Health in the surrounding counties. They know them at the state level. So you got to be cognizant when you go to a stakeholder or you try to develop this relationship and you start burning bridges, you're going to burn all your bridges. Or if you go out there and overpromise and under-deliver, that word spreads. So just remember, everybody knows everyone. The biggest way to cultivate stakeholders is word of mouth. You know, cultivate those first relationships, get them going, talk to people, deliver what you promised to deliver. Even if it's bad news, send that email like, hey, you said you were going to do this for me. Send the email and tell them you didn't do it and, you know, why you didn't do it. Be honest. You have to show up. You can't just like send an email and be like, oh, cool. All right, they're a stakeholder. Awesome. They signed off. You got to show up. You got to put the effort in. You got to be in front of them. The mayor, Chris Field, always says it to us. That showing up is in 75% of the relationship. And that's actually her in the top rate. That's Darlene with two of my summer school students, or some, not summer school, but summer interns who are now full-time employees. It takes time to develop these stakeholder relationships. I tell people it's going to take 5 to 9 touches. So what does that mean? What is a touch? An email, a phone call, meeting them at a conference, talking to them after a seminar, going to, you know, seeing them at some other workshop. Just, they're not going to work with you from the first day for the most part. You have to deliver and you need to focus on their needs. I mean, you want the relationship to be a two-way street. Yeah, we want stakeholders so that we have something to design to. We want stakeholders so we have something to focus our research on. But you need to focus on what your stakeholders want. You'll see some examples later on, but you're working on a better weather forecast or whatever. Who's that for? Is it for your curiosity? Is it for a farmer? Is it for a waterman? Is it for emergency management? You need to keep the focus on your stakeholders if you want to maintain those relationships. And some of these stakeholders here, so this is Paul Emily. He's about 90 years old. He's lived in Crisfield all his life. So why is he up here? So I sat down and talked to him for about 3 hours one day. And, we don't say the word climate change. He doesn't understand that or care. But I can ask him, hey, when you were a kid, what were the grasses like? What was the water like? How clear was it? What'd you guys do? And he can tell me, oh, I remember when we could see 15 feet to the bottom. I remember when the grasses, it was so thick you couldn't even go out there on your boat in the summertime. Oh, I remember when this beach and that beach. So, for us, we cultivate these relationships, talking to these older time people that have been there forever, just to get their perspective, because there isn't really data from, there's some data points, but, getting these perspectives that aren't written down is great anecdotal work for us. Ron Vogel with my favorite angry crabber on the bottom right. So I took a water quality scientist out with a crabber. And I think Ron would say that was actually a fun day, wasn't it? And secret, CJ also used to be a water quality scientist for DNR before he was a crabber. So he's a little dangerous when he starts talking to you. And then in the bottom there, that's Dr. Canty, even Katie, and Senator Van Hollen when we toured Crisfield together. All right, so who's ever heard of a user story besides me? And Jarrett in the back. So user stories are actually from software engineering. Software engineering. They're a way to write a very short story from a stakeholder perspective to give, and software engineering to give the design team and the developers an idea of what's going on. But for us, for scientists, it works the same way. You out and you identify a person, what they want, and what the benefit is for you doing whatever work it is. So it's I want, so that. It's very simple format. So this is from the Dawn program. This is a user story example. So as a grain farmer, I want an irrigation tool that maximizes my yields and minimizes my labor hours. So that's the benefit. Minimizes water usage and utility costs. That also benefits. I want an application that may set up in less than 15 minutes. Doesn't require further input on my part. It should alert me for irrigation situations, be easily be readable, update, and work on my laptop, iPad, cell phone, yada, yada, yada. It should remember my decisions and outcomes. So it should be a little bit smart. So that's an example of a user story. Oh, that tells me everything I need to know. I know who I'm designing it for. I know who I'm working with. I know what they want out of it and why. And I know what that tool should do. So this is further into it. So like I said, end user, grain farmer, what do they want? They want an irrigation tool they can set up relatively quickly that updates and sends them alerts. The benefit, yields go up, costs go down. So then we move into, so some people call this acceptance criteria. Some people call this the definition of done, and you can use this for science. We use this all the time in the Dawn project for other than just developing software. So the scenario, the name of what you want, farmer gets an irrigation recommendation. Given farmer enters their preseason information, when, so the specific action that the user makes. Soil moisture forecast falls below criteria, when the system ends an alert, user makes decision, and then that can continue every 12 hours, it recycles. So by using the user story to develop this short little story that tells you everything you need to know about what you're doing, it doesn't need to be 25 pages of narrative. It's the shorter, the better. And then developing some acceptance criteria and definition of done. you can easily outline out your steps and what you need to do. So for a software tool, this is easy. For developing an algorithm, for data assimilation, for a satellite system, it's the same thing. You know, who's your audience? Why are you developing this algorithm? Why are you doing this data assimilation? You know, what do you want it to do? What do you want the outcomes to be? What do you want how does it reprocess? When's it update? This is just additional hints and ideas that we've come up with over the time. Concise, the shorter the better. This evolves over time as you work with the user and you start developing parts of your science and you start developing parts of whatever your software. It's going to change. It's going to iterate. Start early. Start with your users before you start with your science. Every story is geared towards development of one thing. You don't list 27 different objectives. We're targeted on one thing that we're working on. Collaborative development works the best, and we'll talk about that a little bit later. Developing that relationship and being able to freely talk with people is crucial. You need them to open up and really tell you what they want when you're working with stakeholders, because sometimes they don't know. People my age and older laugh about Donald Rumsfeld, but I tell this story to people that are my age and older. He got up there and famously said, there's the known knowns, the known unknowns, and the unknown unknowns. And it sounds kind of crazy until you think about it. I know what I know. I know what I don't know. What's going to hurt me is what I don't know. I don't know. So we're trying to figure out what we don't know. We don't know. Because a lot of times when on this side, in this building, and the science side, we don't know what the stakeholder really wants. And a lot of times they don't know what they really want until you actually work with them and have these conversations and start walking, you know, with them together and figuring this out. So the user story, I want, so that. And then this is kind of a dawn note for us, but a tool is a decision support tool that provides information used in making a decision. So if you're doing this for a purpose to make a decision at the end of the day. So what does this look like for those that are like to have a visual? So this top arc, here's my mouse. This is the user side. This bottom is the scientific development side. So users, scientists come together, we create these user stories, we develop the user story. On the science side, we start whatever model design development, working on our science. We give them a prototype. We deliver the prototype and the user evaluates it. And they say, yay, nay, fix this, fix that, whatever. I don't like it. Doesn't do what I want it to do. Can you make it faster? Can you make it smaller? Why does it take 5 days to run a model of the entire world at 1 kilometer resolution? Can't you even do that faster for me? No, I cannot. But as you can see, these all loop back. So you'll find once you start working with stakeholders, there's a lot of circle, there's a lot of iteration, there's a lot of going back. And that's just part of the process. But at the end of the day, when you're done, you've delivered something to your users that they can actually use and want to use, and will incorporate into some of their planning and some of their workflows. So these are some of the partnerships and some examples of how we've worked with this over the past couple of years. Has anybody ever heard of the cat laboratory on the campus besides Ralph and Lawrence and Cassie? You guys, you guys too. So about 2 miles that direction before you get to the runways, and this very non-discrete looking building, you go in there and they sit you in a conference room that has 25 $1,000 office chairs sitting around a table that's in a room full of nothing but TVs. It's kind of crazy. But anyway, so basically what this cat laboratory does is they work with traffic and emergency management data across the globe, mostly in the US, but across the globe. So some of our partners at AOC, Russ Dickerson, and Ed Strobeck, they've been working with them using the traffic data to analyze emissions, especially the ultrafine particle concentrations of black carbon. So, okay, great. They have data. What does that look like? So this was a screenshot this morning. This is all these little dots are all the areas where the state of Maryland, and this is only for Maryland, they're tracking traffic. So you can see a little blow up there at the bottom. It tells me how many cars are going by per minute, how much they're going, how fast they're going. So I can use this information and we can get this data downloaded in a sheet. But I can use this information for the last 5 years to look at traffic volumes and look at air quality readings and look at air quality models. And I can start using this traffic data, start estimating emissions and seeing how it changes with traffic. We can also see if it's a heavy truck or not too. So this is kind of the working with stakeholders. So we have air quality scientists working with this traffic lab, and they're using, this information for for something that wasn't really designed for. This was designed for traffic management. But we're using it as a side purpose. We also use it for flooding. So this was during Hurricane Debbie on the left. I pulled that this morning from the database, but this is just like a couple lines out of a couple hundred. But it'll show me everywhere where the roads were flooded in Maryland. And on the right-hand side is our hydrograph and the NOAA weather that responds to the event. So we can look at our flooding data, we can look at our sea level sensors, we can look at the weather data, and we can go back and pull up where were there floods in the state of Maryland that impacted traffic. So now we know we can put all that on a heat map, we can put all that in GIS. Now we know the areas where flooding affects the roadways the most. So we can start talking to those communities about whether they want sensors, whether we should do better flood modeling or those things. So that's the way we can use this other data that we get from these partners in ways that don't seem completely obvious from the get-go. Another kind of a sister project, it's not really ours, but it's paid for by MDIM, which is Maryland Department of Emergency Management, is the Mesonet. If you don't know what the Mesonet is, the state of Maryland hired the University of Maryland to put in 79 weather stations across the state. 75. Well, what about Montgomery County's other 4? Anyway, basically the idea is to fill in the map for real-time weather data. So no station is further than 12 miles apart. So these are robust weather stations. The weather data is fed right into the National Weather Service. It's real-time data. Like I said, they're not filled in yet, but Montgomery County actually bought extra stations and they're going to pay University of Maryland to manage them because they're worried about their flooding. So working with the Mesonet, we can go out into the communities and we can talk to them and we can bring them this better scale data. This Mesonet also has soil temperature, soil moisture at depth. So it gives us a lot of information we don't get from the Weather Service, and it's on a much tighter grid. Well, yeah, you get everything there, including snow depth, which from time to time, depending on how it snows, can get a little wonky, but it'll reset after about an hour or two and go back. So during February, when we had the ice storm, there was one station on the eastern shore that was showing like 6 feet of snow for a couple hours because something happened with the sensor, but then it cleared itself. But like I said, these are going to be all over the state. So now we're going to have real-time, real data. Does it measure at the second?
Every 3 seconds.
So it's measured everything, but we can do every 3.
Down at 3 seconds.
Yeah. So minute data everywhere across the state. So there is a story building here. So this is Karen Prestegard's work. She is a hydrologist. She actually was my professor, and I don't want to age her, but in 1991 for groundwater geology and 1992 for surface water geology. But basically what she's been looking at is the impacts of climate on the precipitation patterns in the state of Maryland and how that affects runoff. And she's been concentrating on the fall line. For those that don't know where the fall line is, we're in the coastal plain. If you start driving west, you start seeing rocks. You'll see the fall line. You know where Great Falls is? Everybody know where Great Falls is or heard of that? That's the fall line. You know why, if you go down 95, why it's on the fall line? Because all the cities are as far as you could take a boat up the river, and then they stopped. Anyway, so she installed a bunch of gauges in the tributaries with her and her students, and they used USGS data. And they were looking at how fast streams transfer precipitation into runoff. So she's looking at flooding on a micro scale, small watersheds, neighborhoods, zip codes, things of that nature. So then Montgomery County floods. So we start working with the National Weather Service with the lead hydrologist in Sterling, Jeremy Geiger. And the Weather Service, they put out these awesome forecast, flash flood watches, warnings. The problem is the emergency managers want more lead time and they want a better spatial resolution. Okay. So we work with the Mesonet. We work with Karen Prestegard, who's doing flash floods and hydrology. We bring us all in the same room and start working together. And then we bring in also students like this who can program and do stuff. And we're working together to come up with a better flood model, flood prediction model at a higher resolution, a longer spatial or longer temporal warning or lead time, smaller spatial resolution. So we can bring in our real-time soil moisture data that they didn't have before and a little mathemagic with the machine learning. And now we know, are we saturated? Are we unsaturated? Are we dry? How much water, how much capacity does that soil have to absorb water before it starts running off? Working with emergency management in Montgomery County. So every time a car does this, it costs them at least $100,000 to show up and get that person. And also, when they do that, they have to take a bunch of equipment out of service. So now they have to move a bunch of equipment around. So it really ends up costing them about $200,000 a rescue, which starts to add up to be real money real quick. Unlike the federal government, they just can't pretend like they have money. They have to actually have it. Sorry, went too far. Freshwater salinization. Who knows about this topic? Who remembers Flint, Michigan? Flint, Michigan was salinization of the water. They switched water sources that had more chlorine ion in it than the previous water source. And it started eating away at the manganese, the lead, and the welds. So Suji Kushal, who works on campus, we started working with him. Watts Branch drains about, I don't know, 95% of Rockville in Montgomery County. USGS had no gauges on it. Nobody was doing water quality measurements on it. And Watts Branch, why is that significant? It empties into the Potomac River less than a mile upstream of where the Washington Suburban Sanitation Commission pulls the water from the Potomac River for the drinking water for the area. So he's been looking at salinity for a long time. And once the salinity gets in the water, getting it out, besides reverse osmosis or desalinization plants like they have in the Mideast, is almost impossible. So, okay, so there's salt in the water. Awesome. What's that do? Well, like in Flint, Michigan, you put this through an agent system. It starts corroding. It starts corroding valves. It starts corroding joints. You put it in old houses, especially in DC, where you might still have a lot of lead or lead joints or lead solder. It starts eating away at the lead, which is not good for people. He's also been studying with the Chesapeake Bay program, just increasing salinity in our water system everywhere. And this also starts getting into groundwater. So people with wells, people on the Eastern Shore, you start seeing the salinity go up. And, for irrigation, the closer you are to the water, you might not have any water to irrigate, or you just might have salty water that's killing your crops. So this is another way that we work. We work with Sujay, and then we go out and we've been working with the farmers on the Eastern Shore and geography on climate impact and salinity in the soils. How is this increasing freshwater salinization affecting land use? So one of our other partners, geology, we've been working with the Maryland Department of Agriculture and the Department of Natural Resources. Department of Natural Resources has this really cool flood mapper that they took years to develop. And you can go look at past events. You can go look at simulate future events, and we're working on getting our data there. But in geography, we've been developing these dashboards for the Department of Agriculture using the satellite data, pretty much all satellite data. So if you go to their website, the one on the top left is actually salinity, saline soils. So we give this information to MDA, we give this information to the ag advisors, we give this information to the farmers, and they can use that hopefully to make better decisions. All right, Hydronet. So this one is actually a project that I'm on a lot. I guess I'm the project manager, so I guess it puts me on a lot. So many years, or when this project first started, we had these sensors in here for a meeting. And we talked about we could put these where you are and we can measure sea level and give you real-time sea level. And we asked if anybody wanted one. Everybody's hand went up. So we've been trying to fulfill that ever since. So these are our fancy pictures with Daryl Pines and Amitabh and Tim Canty and mayors and county executives and Mike Henson, the director of resilience for the state. So we've been putting these sensors out across the bay. So what do we do with that? So the map on the top left is where we've got them, where we plan on putting them. The purple is the federal system. So you can see the space between the purple dots and all of our dots. We generate the bubble plots so we know the meteorological conditions that cause flooding and the conditions, and we have dashboards that where you can pull them up and see all the flood data at one time. Okay, great. People have flood data. So we've been working with emergency managers throughout the state on updating their flood mitigation planning. And also we've been working with planning and zoning, updating their flood zone maps. So that's where this information comes into play with the stakeholders. So we've also been working with, you'll hear Chrisfield a lot. So all these little orange ones without the fork and knife are places where we've gone out and surveyed how high the land surface is. The blue is our sensors. The yellow is a sensor that's going to go in. We know the meteorological conditions. But what we didn't know until we started studying this is when they have high tide anomalies, 10 days later, they have Enterococcus bacteria at their public beach. Enterococcus bacteria is a fecal coliform. So, we can look at with these sensors and with our team going down there, working with them, asking them what their problems are. We were able to give them this information, which they didn't know before. So now the community has the information. So when they go in for a grant or go talk to the Department of Health, they can say, hey, we need help here. We got this problem going on. We also have this alert system. This is one of the emails that we'll send out. So this is for Chrisfield. Once it hits a flood threshold, we send it out. They get it. So right now it goes to their director of public works, their mayor. Once this is fully vetted there, anybody is going to be able to sign up and get these alerts for any of our stations anywhere that we have them in. And just to show kind of difference in tides, the green is Chrisfield, the blue is Annapolis. So at this high tide event, Chrisfield's almost is 2.5 feet. And then the corresponding high tide for Annapolis is only about a foot or half a foot above the mean low water mark. So it just shows you that having 1 gauge or 2 gauges in the Chesapeake Bay is not sufficient for the communities, especially when they have to make a decision. Like this one in green is right at the hospital, and they have to decide whether or not they're going to send their emergency management vehicles to the hospital on one way that's going to get flooded, or if it has to go a different direction, it takes 45 minutes extra to get there. So these are the kind of decisions people are making with this information. Also, if I back up, this is Cobb Island. They have the same problem. They have a bridge that floods out. They have to decide whether or not they're going to pre-station emergency vehicles on the island, because once it gets too high, they can't get to the people on the island. All right, our stakeholder workshops. And I know this is Lars Peter's favorite name, Science Serving Communities Advancing Climate Resilience in Maryland. Little joke, inside joke. So in 2024, we started in this room. We had a stakeholder workshop. We had about 50 people here. We did a series of lightning talks. It was only people that work for the Climate Resilience Network. And it was good. And we had a lot of positive feedback. We learned a lot from it. So the next year, it got a little bigger. We had 125 participants over 2 days. And once again, we learned. And in 2026, we had another workshop for over 200 participants showed up for over 2 days. So that's pretty substantial growth. I don't think we're going to get that much growth this time, So we went from having presenters that only worked for the Climate Resilience Network to presenters across the campus to 6 regional universities participated in last year's. I went really fast. But that is, us developing our stakeholders and working with our stakeholders. We take this information from this conference and use this to guide what we're going to be doing over the next years. Oh, this is wordy. I don't like wordy, but this were the key findings. The big takeaway for down here for this talk is the section, down at the bottom there, communication and building trust is key. You got to listen to the requirements, transform your data into something actionable, some actionable form. What you consider actionable may not be actionable to a user. Regularly assess and clearly communicate uncertainty of data. That is difficult. I will let you know that right now. What we say to each other, mean absolute error, root mean square, height key scale score, Nash Sutcliffe, whatever we want to use. If you say that to somebody that is the emergency manager in Dorchester County, they're going to look at you like you have 17 heads. You need to figure out a way to explain uncertainty in a way that makes sense to the people that you're working with. And you need to have access to multiple tiers of users. It's not just, if you want this to be out in the stakeholders' hands, you want this to be used by people. It's not just science designed for scientists. And be aware of the valley of death, which is the chasm between research and operations, or as I say at the beginning, in the paper that I like, he calls it the mucky middle. I call it where science goes to die. They all say the same thing. And this is everybody. This is people we've met over the years, places we've been. I can walk you through them, but obviously this is Washington, D.C. This is Sarah Elfrith. She's the congresswoman for the Maryland's 5th District now. This is the National Geodetic Center in Virginia. Senator Van Hollen. I chopped up Darlene's head. Paul Emily, my man. He was an interesting cat because he made me go to church with him the next day. And then he showed off a bunch of paintings down there. So, sidetrack. Chris Field's famous, the Wood Brothers, for ducks, for making decoy ducks. Like some of their really good ones go for $100,000, which is insane. But the one brother carved, the other brother painted, and then the church is a bunch of his original oil paintings, which are pretty interesting. And like I said, I went fast, but these are some of the people we work with. Thank you for coming. I probably have plenty of time left. So anybody have questions? I didn't include you guys.
Online attendees
There.
can raise their hand, and in person can just wave me down.
Thank you for your talk. Impressive work. I'm just curious if you have all these data stream that you can get and provide real-time products that can produce action and affect real and affect lives people. I was wondering if you ever thought about real-time dashboards for smart cities, monitor cities in real time.
So
I don't know if you have it already, but
we do have some dashboards already. One of the problems is we have them all on different sites. I've actually been working with some AI tools recently because, a lot of times I write these data management plans for a group that I work with, and it's always the findable, accessible, interoperable, reusable. And what I find is when I use the AI tools to check that, it is not. So it's one thing, not just us, but everybody needs to be more aware of is, we just put a proposal in for working on some of this with NSF, but In 5 minutes, we found 20 sites just in the state of Maryland that offer data for watershed management. So if you multiply that by Virginia and Pennsylvania, if you're a watershed manager or work for the Department of Natural Resources and you need data, you almost need to have a person that's a data and web expert to find it. And that's one of the big problems. I think it's a big problem in science is researchers, we all do it. I'm guilty of it. You got a project, the first thing you do is make a website and show our data. The other day we had a meeting in here, and one of the things I was thinking was, man, ESSEC has a lot of websites that have data on them. We should really come up with a way to unify the way we're presenting our data, especially if we want users to use it, because they're going to get frustrated and they're going to just give up because they don't have time to try to figure out where 50 websites are, and then this one's in millimeters per hour, this one's in gallons per hour, this one's in who knows. Download a netcdf file. Well, I don't know what is a netcdf file. Download a bill file, download a grid file. You know, if you're a water manager or you're an environmental scientist or emergency management, you don't know what these formats are or how to deal with them. You know, like Chrisfield, they have a mayor, she has an assistant, they have a grant writer, they have a director of public works, and they have a chief of police. That's it. That's their office staff. So if anybody sends them a GIS map, they have to go find somebody to do it for them. If somebody sends them an engineering plan, they have to find somebody to read that for them. Fortunately, we do that for them. But yeah, it's a big problem in the community is, you know, we think of it, we have our way of talking, they have their way of talking. We got to make our way of talking their way of talking. And hopefully that's kind of what I try to do is help you talk to them and them talk to you. And maybe we can somehow in the middle meet.
Thanks, Mike. This was really interesting. I have a question about this relationship between us and stakeholder. Let's assume we somehow cross this valley of death that you said, and you have good relationship. How many typically strikes you have before only one? Wow. Okay, that's intense. Then, what's the most often reason why the relationship breaks?
You're just not delivering a value product for them.
Only once. Wow.
Well, think about it this way. You go to a restaurant, right? How many times do you have to have a bad experience before you say, I'm not going back? It's the same thing. And so before I came back to school, I worked in restaurants. So, and before I came back to school in 2007, I worked in restaurants for 15 years and owned a restaurant. And that was the value proposition. You could have a customer that comes every month. You mess it up once, gone. You get one shot, even valued customers. Another thing I learned, because I also did food sales, they told us never ask anybody how they're doing because they just might tell you.
There's an online question from Louis.
Uh-oh.
No, it's more of a comment. Nice. This was really great, Mike. You really brought a lot of material to the table. I thought I would just build on it in two examples. One was at the WMO, and I know I have to be careful here if Lars is in the audience because he was at the same meetings in 2019, and one of them at the big Congress was, you know, how do you deal with societal needs? And it had a basic almost 75 people around this big table, and only 4 or 5 mentioned listen first. You go into a meeting, and we're talking about all over the world, but these 4 or 5 were really strongly stated, and it certainly left an impression on me. Listen first, listen always. And the kinds of things you just laid out here lends itself to all these management charts too, as long as you factor it in as not just a sort of a nice thing to do. It's essential. And you have to come when you have your next meeting after the first meeting, you have to basically say, this is what I heard. you have to confirm. So that was point one. Point two was you talked about the locals knowing everyone, around the counties. They also know all the politicians, and they come back to them. So you're actually building up local and state support as you interact with these people. As long as the next time you come back to them, you tell them what you heard and what you're doing, and that they're part of the process of assessing what you're doing for their needs. And the last thing I'll say here is, you got Cecil County on here. Between Cecil and Criswell, those meetings, what a learning experience for each one. So for Cecil County on the north part of the Chesapeake Bay, we all talk about the Susquehanna and how important that is with respect to driving and then you have your meeting with the Cecil County emergency managers, and they talk about the other three rivers that they have to deal with, which means, from a Hydronet perspective, you're not dealing with one system up there, you're dealing with four. And maybe you need two for the Susquehanna. All right. So that was one thing. And then Crisfield was really interesting, as you pointed out. But what you have to envision as you're driving towards the bay from the east, they got a berm that goes right down the middle, basically splits Crisfield in half. To the north of that berm, they have one river, and it'll flood if you have a northwest wind. The river to the south of the berm will flood if you have a southwesterly wind. So what that tells you is that you need to have these wind fields. So when we start looking at the mesonet now, we're trying to get 3 stations of mesonets in the middle of the bay at the old lighthouse location. So, you start really learning what you've got to do, even as you're developing these projects. And these folks will go to the local and federal Congress people who represent them and tell them how important this work is. So it's been quite an experience working with you and Tim and the others and the folks in geology, of course, as we've learned right down to the micro scale almost how these folks can use the data to make really life-saving decisions.
Thank you. And that Valley of Death, that original paper was 82, 83. It goes way back.
Yeah, and the National Academy of Science actually has a report that they did in 2001 or 2000, trying to rescue the U.S. Weather Research Program, and right on the cover, crossing the Valley of Death. All right, so it's not a term that was just made up. It's really been a concern to those that have been involved in R2O for a long time.
Thanks, Larry. Any other questions in person or online? All right, well, let's give another big thank you to Mike.
That up there for you.
Thanks to everyone who is attending. That's our last seminar of the semester. So have a great afternoon.
Nice.
I didn't have a clock with me.